Our solar system feels like a familiar neighborhood, a place where the planets, moons, and asteroids follow predictable paths around our sun. For centuries, astronomers have mapped its every corner, believing we understood the cosmic traffic that passed through our celestial backyard. But in 2017, everything changed in an instant. A strange, fast-moving object was spotted hurtling through the solar system, unlike anything seen before. This object was soon named Oumuamua, Hawaiian for messenger from afar arriving first. It was the first confirmed interstellar visitor ever detected, a true outsider from another star system, passing through our own. Its path was a hyperbolic arc, a clear sign it came from beyond our sun's influence and would never return. The discovery sent shockwaves through the scientific community and captured the imagination of people around the world. Its arrival was brief but electrifying, sparking global excitement and debate. Astronomers raced to observe it before it slipped away, knowing this was a once-in-a-lifetime opportunity. Oumuamua was small, perhaps just a few hundred meters long, yet its elongated cigar-like shape and rapid rotation made it unlike any asteroid or comet we'd ever seen. It was moving so fast that it was clear this visitor would never be captured by our sun's gravity. Its reddish color hinted at the presence of organic molecules on its surface, possibly altered by cosmic rays during its long journey through interstellar space. But its most puzzling trait was its acceleration away from the sun, without any visible tail or gas, defying expectations. Normally comets accelerate like this as sunlight vaporizes their icy surfaces, creating a tail of gas and dust. But Oumuamua showed no signs of outgassing, no shimmering tail, just a silent, tumbling motion through the void. Scientists scrambled to explain it. Was it a fragment of a distant world, a shard of cosmic debris, or something entirely new? The mystery deepened with every observation. Theories ranged from solid hydrogen or nitrogen ice, which could sublimate invisibly, to more exotic possibilities. Some even speculated about alien technology, though no evidence supported that idea. But before we could solve the mystery, Oumuamua vanished into the darkness, slipping beyond the reach of our telescopes and leaving us with more questions than answers. It was a fleeting encounter, a cosmic puzzle that challenged everything we thought we knew about our place in the universe and the objects that pass through it. And as we look to the stars, we wonder, what other mysteries are racing toward us from the depths of interstellar space? For scientists and dreamers alike, Oumuamua was only the beginning. After Oumuamua's departure, scientists pored over the scant data. Its elongated shape and reddish hue suggested a fragment battered by cosmic radiation, perhaps rich in complex organics. The leading theory, a chunk of frozen nitrogen, like a shard from a Pluto-like world, accelerating invisibly as it neared the sun. But this idea had problems. Such objects should be rare, and surviving billions of years in space seemed unlikely. Other theories emerged. Was it a cosmic dust bunny, or just a strange rock? With so little data, every explanation was speculative. Oumuamua became a cosmic Rorschach test, reminding us how much we have yet to learn. Years passed, and the cosmos seemed to return to its quiet, mysterious rhythm. Astronomers continued their patient watch, scanning the heavens for any sign of another visitor from the stars. Each night, telescopes swept across the sky, collecting data, hoping for a hint of something extraordinary. Then, in July 2025, everything changed. Astronomers spotted something new. 3I/Atlas, the third interstellar object ever found. The news spread rapidly, electrifying the scientific community and capturing the imagination of the public worldwide. This was no tiny fragment. 3I/Atlas was estimated to be up to 20 kilometers wide, dwarfing Oumuamua and even most asteroids we'd ever seen pass near Earth. Its sheer size was staggering, making it a true behemoth among interstellar travelers. Statistically, we should have seen millions of smaller objects before finding one this massive. The odds of discovering such a giant first were almost unimaginable, challenging everything we thought we knew about what drifts between the stars. Its size alone shattered our expectations. It forced scientists to reconsider the processes that shape and eject objects from distant star systems, and to wonder what else might be lurking in the dark between the stars. Detected far from the sun, 3I/Atlas was on a retrograde orbit, unusually aligned with the plane of our solar system. This rare trajectory made it even more mysterious, as if it had been flung toward us by some cosmic coincidence. This odd path through our solar system only deepened the intrigue. Was it a random wanderer, or was there a story written in its journey? The astronomical community mobilized instantly, determined not to let this unprecedented opportunity slip away. Teams around the world coordinated observations, sharing data in real time. 3I/Atlas was a paradigm shift, a colossal, improbable visitor that forced us to rethink our models of interstellar debris. Its arrival was a wake-up call, a reminder of how little we truly know about our cosmic neighborhood. What was it made of? Was it rock, metal, or something entirely new? Scientists raced to analyze its composition, hoping for clues about its origin. Where did it come from? Could we trace its path back to a distant star, or even a long-lost planetary system? The questions multiplied as quickly as the data poured in. Its presence promised answers to the mysteries Oumuamua left behind, and perhaps even more profound questions about the nature of interstellar visitors. The race to study it had begun. Every telescope, every instrument, every scientist was focused on this once-in-a-lifetime event. For the first time, we had a chance to truly examine an interstellar giant up close, to unlock secrets that had traveled light years to reach us. The universe had sent us a new messenger, one that might forever change our understanding of the cosmos and our place within it. Comparing Oumuamua and 3I/Atlas reveals striking contrasts. Oumuamua was tiny, fast, and mysterious. 3I/Atlas is a giant, offering a wealth of data. Both objects, however, share a baffling trait. Neither shows the classic cometary tail. For 3I/Atlas, this is especially odd. An object of its size should be erupting with gas and dust as it nears the sun. Instead, it remains silent, just like Oumuamua. Their surfaces differ too. Oumuamua was reddish. 3I/Atlas appears bluer, hinting at different origins or histories. These differences and similarities suggest interstellar objects may be fundamentally unlike anything in our solar system. With each new visitor, the pattern of strangeness grows. The universe, it seems, doesn't play by our rules. We're only beginning to learn the language of these cosmic wanderers. The missing tails of both Oumuamua and 3I/Atlas are at the heart of their mystery. In our solar system, comets display bright comas and tails as they approach the sun, yet neither interstellar object shows any sign of outgassing, despite 3I/Atlas's massive size. This forces us to consider radical possibilities. Are these objects born dry, or have they lost their ices during eons in interstellar space? If so, their composition and origin challenge our models of planet formation. The lack of a coma isn't just a detail, it's a profound clue. These silent travelers defy expectations, hinting at unknown processes shaping worlds beyond our own. The mystery deepens, and with it, our curiosity. What lies inside these enigmatic visitors? The most astonishing fact about 3I/Atlas may be its age. Tracing its path, scientists found it likely originated in the thick disk of the Milky Way, a region of ancient stars. 3I/Atlas could be up to 14 billion years old, predating our sun and planets by billions of years. It's a relic from the galaxy's youth, a time capsule from an era when heavy elements were scarce. Its composition could be unlike anything in our solar system. Studying it is a chance to peer back to the dawn of the cosmos. 3I/Atlas isn't just a visitor from another star, it's a messenger from another epoch. What secrets does it carry from the galaxy's earliest days? When nature's explanations fall short, our imaginations turn to the extraordinary. Some scientists like Avi Loeb have speculated, could Oumuamua, or even 3I/Atlas, be artificial, perhaps a probe or relic of alien technology? The idea is controversial, but the anomalies, strange shapes, unexplained acceleration, massive size, keep the debate alive. While most experts favor natural origins, the possibility of design can't be entirely dismissed. The conversation pushes us to gather more data and keep an open mind. Extraordinary claims require extraordinary evidence, but the questions themselves drive exploration. In the search for answers, no idea is off limits. 3I/Atlas presents a rare opportunity, and a race against time. What is it made of? Why no coma? Is it a solid monolith or a loose collection of fragments? The answers require hard data, but observation windows are limited. As 3I/Atlas nears the sun, it will be hidden from Earth for months, making every moment of observation precious. The world's most powerful telescopes, Hubble, James Webb, the Very Large Telescope, are all focused on this visitor. Soon, the Vera Rubin Observatory will scan the sky for more interstellar objects, ushering in a new era of discovery. We're moving from scarcity to abundance, building a catalog of cosmic wanderers. Each new object will help us understand whether Oumuamua and 3I/Atlas are outliers or the first of a new class. The tools are ready, the universe is waiting. The quest for answers has only just begun. The stories of Oumuamua and 3I/Atlas are more than just scientific curiosities. They are cosmic messages, sent across unimaginable distances and timescales that challenge us to rethink what we know about our universe. These mysterious visitors remind us of our place in the cosmos, sparking wonder and humility as we gaze up at the stars and realize how much remains unknown. When objects from beyond our solar system pass through, they shatter our comfortable models and force us to confront the vastness and unpredictability of space. Each new discovery reveals a universe far stranger and more complex than we ever imagined, filled with phenomena that defy our expectations. These interstellar objects connect us to a larger story, one that stretches back to the dawn of time and forward into the unknown future. Humanity has always looked to the skies for answers, from ancient civilizations mapping the stars to modern scientists probing the depths of space. The search for answers is driven not by immediate utility, but by a deep curiosity, a testament to the enduring human spirit of exploration and discovery. We are compelled to explore, to ask questions, and to seek meaning in the mysteries that surround us. As we await more data and future discoveries, anticipation grows. Each new observation could change everything we think we know. We stand at the threshold of a new era in astronomy, with powerful new tools and technologies opening windows into the unknown. We are no longer just passive observers of our solar system, but active explorers reaching out into the galaxy. Our spacecraft now travel beyond the boundaries of our home, carrying our curiosity into the interstellar void. The secrets locked inside these ancient travelers could rewrite our understanding of how planets form, how stars are born, and even how life itself began. Each fragment, each clue, brings us closer to unraveling the mysteries of stars, planets, and our own cosmic origins. The universe is speaking through these cosmic messengers, offering us glimpses into its deepest secrets. Our job is to listen, to learn, and to keep pushing the boundaries of what we know. We must never lose our sense of wonder, or our willingness to marvel at the unfolding mystery of the cosmos. The adventure is only beginning, and the universe is waiting for us to discover what comes next.